Okay, no? So, anyway, this class is recorded, no? So, para sa katong absent, makita nila, no? So, okay, no? So, again, no? May ngunto, no? Nakita nyo akong gi-share, no? Introduction to Octave. Klaro ra?
Yes, sir.
Sige, no? So, again, no? May ngunto, no? So, introduction to Octave, no? So, last meeting we discussed about financial math, finance, compounded interest, simple interest, perpetuities, annuities, and a lot more, no? Those are part of the applied mathematics in kuan ba in finance, no? So today is we will discuss about more on still part of applied mathematics, but it's more on computer simulation, no? So I understand, no? Most of you are computer related courses, no? Tama ba? Computer related courses, and there are part of your curriculum is programming, no? Sakto ba? Programming? Most of you, no?
Comtech, sir.
Comtech, but I believe, no, since this is computer, no? So, why I'm introducing this, no? Because the trend today is more on computer simulation, no? So, the applications that before you in an application before you manufacture or mass produce the product is you ensure that this is already perfect, no? And one way of looking at or ensuring, no, is through simulation, no? There are a lot of simulation software around, no? And since this is the application of math, so the two common application software in the market is the Matlab. I hope you heard that Matlab. Kinsa may nakadungog og Matlab and kabalo sa Matlab? Anybody? So you probably heard that, no? And Octave, no? So Octave and Matlab is similar. But the difference is that Matlab is commercial, no? So meaning the license is very expensive, no? Unlike Octave is open source ni ang Octave, no? So open source. So that's why I'm selecting Octave to be our software or simulation software to do some mathematical simulations, no? So there are a lot of tutorials in the internet, but since this is a class, I'll be guiding you some basic computations on how we're going to navigate Octave, no? So first is, what is Octave, no? So Octave is a high level interpreted language, no? Build within is the intentions of numerical computation. So meaning Octave is more on numerical computations gid siya, no? And has capabilities for data visualization, no? So nasa siya data visualization like graphs, no? Graphs, we wanted to see the graph, no? So primarily ang purpose of Octave is prototyping, no? As I've mentioned, no? This is a prototyping tool, no? Before you implement that let's say an example or a simulation to other languages, no? Or let's say in a manufacturing or mass production, no? So that is Octave, no? So this is Octave also makes it incredibly fast, no, to implement ideas from many fields of math and data analysis, no? So Octave is not only pure math, but it has also the function of data analysis, no? Octave is free, no? Free siya compared to Matlab, no? Matlab is popular but very expensive, no? So Octave has ability to plot graphs, no, and data straight out of the box, no. So later we have examples on how to simulate some problems in math that we're going to visualize through graphs, no, using Octave command, no. So generally, if you have computers at home, laptop, PC, so you can actually download Octave using this URL, so www.gnu.org, software.octave, so GNU is the developer of this is a crowdsource organization, or you just search Octave and install, so Octave, so okay, so now we have basic operations of Octave, since I mentioned that uh, Octave is more on math, we have some basic operations on Octave, so ang naka nindot manggod sa software simulations is when you when you perform complex computations, unlike in manual na mag-solve ka and then a lot of operations then masayop ka. Here, when we're using computer simulations or machine learning, like for example, is we just enter the code and let that machine perform complex computation and give you the answer. What is important is the answer only. Okay, the answer may be an aid for decision making or an aid for mass production, or what we call to kanabang to correct, to correct some issues like in manufacturing, for example, if this is an applications for that, so so far okay ra, klaro na sabtan ako ninyo class. Okay ra, I hope okay ra,
Yes, sir. Yes, sir.
Okay, nakita ra niyo akong i-present,
Yes,
Yes, sir.
so okay,
Yes, sir.
so we have basic operations or Octave. What are unsa man ning basic operations in mathematics? Of course, these are the addition, subtraction. Okay, that's the basic math. So I'm be opening Octave. So I have pre-downloaded Octave here. I hope you see it. So in the left side of my screen, these are the kanang ginatawag nato og for a while. These are the command history, so tanang mga history na dire, and in the right side, because I've divided this into two parts, is what we call command window, so this is the command window of Octave, for example, we have 10 plus 10, plus 10, of course we know that the answer is 20, so the answer is 20, so what if we will type 100 minus 1, okay, so the answer is 99, okay, so we'll have another operations. What if we have what is the decimal equivalence for 3/4, for example, we know that 3/4 is actually 0.75. Okay, what is the value of pi, for example? We know that pi is 3.1416. And what is the value of E is a constant with 2.7183, So that is the basic operation of Octave. And if we wanted to clear the screen, just type CLC and then that screen is clear, So Octave also has an operations of exponents like 3 raised to limbawa asam tong raised to dahil lang ha pagkita pa na akong raise sign, okay, so asa naman to, okay, later lang, okay, nawala sa akong screen, okay, so for example, we have I have a text here, so text, okay, so and assign the text is, for example, hello MCC, and then I have, okay, so okay, so sayop, kulang dahil, CLC sayop, so I have an operator called text, okay, and open, and then I say hello MCC, okay, so the text equivalent is hello MCC, no? If I'm going to recall that hello MCC, I just type text and then it will appear hello MCC, no? So I can also assign, for example, I can assign A equals to 5, okay? Okay, or C equals to 5, okay? And then I add a colon there, no? And the colon is an operator where there's no output, no? And then I put also B equals to 2, for example, and then I put colon, no? So if I'm going uh, to to get the product of C and B as A equals to C plus B, okay, C plus B, for example, and then A is equal to 7 because my C is a stack register with the value of 5 and my B is a value of 2, no? So for example, if my D is equal to sample, no, C times A, okay, so we know that okay, we know that C is equal to 5 and times A, which is 7, which is actually the sum of C and B, and that is equivalent to 35, no? So it's just like a calculator, no? So but the function is more than a calculator, no? For the basic operations, okay, we can use this one as calculator, no? So okay, no? So let's go back to the slide. Okay, so that is the basic operation of Octave, and then we have also an operations in Octave that we call vectors, no? Vectors, no? So we know vectors, no? We've discussed a lot on vectors in our physics, no? In our math also in high school, no? So we've discussed vectors, no? So we have what we call row vectors, no? And example, no? Vector R would equal to 1, 2, 3, 4 or 1, 2, 3, 4 with a comma. We have also a row-oriented vector, no? We have also what we call column vectors, no? For example, here C is equal to 1, 2, 3, 4, and we have also a column oriented, okay? It's a clerical error vector, no? So okay, no? So we will go to Octave, no, to try this out, no. So again, no, here is my Octave command window, and I wanted to clear those previous computations, so just type CLC, okay, the short for clear screen, no. So for example, no, I have a vector R as our in our slide, and then I have here, no. Okay, 1, 2, 3, 4, and okay, let's find out what happened. Okay. Okay, so okay, R, this is my vector R, no? So if you remember, no, in R. So what if I also add a comma, no? So sample in a form of I have a vector C and it's equal to okay, 1, comma 2, comma 3, comma 4. Let's find out what would be the output, no? So same, no? Even if I just separated it by spaces or space or just a comma, no? So the operations is a vector, no? I have a vector of 1, 2, 3, no? So okay, no? So I hope it's clear, no? So those are vectors, no? Vectors, this is the row vectors, and that second example is what we call column vectors, no? So next function that I wanted to discuss to you is matrices, no? Or matrix, no? So matrix, no? So matrices, no? So I hope you're familiar with matrix, no? because this is one of the basics in algebra, no? Um, so we can also put a semicolon similarly to vector or none, no? So I'm going to Octave, no? Octave environment, and I'll type CLC, no, to clear the screen, no? So for example, I have a matrix here called let's see, that's M, no, for matrix, and then I'll 1 2 3 4, no, that's a matrix, no. Matrix is a vector also, no, so don't be confused, no, because matrix is also a vector, no. So that's the output, no? 1 2 3 4, no. What if I separate M, okay, or A? I'll assign another operators here. A, vector A with 1 2, and then I have here semicolon 3 4, no. What's gonna happen, no? Okay, so okay, so error, no. So we have an error, no, because 3 and 4 is it's not separated, no. So just clear screen this. Okay, so for example, I have a vector A, and then 1 2 semicolon, okay, 3 and 4. Okay, okay, so what happened, no? So what makes the different, no? So the matrix is now in two columns, no, 2 rows and 2 columns, no. So previously, if I did not put an operator at the center, no, or the semicolon at the center, so the vector is straight, no. So one row only, no. But when you put a semicolon at the center, it divides into a 2 column and 2 row matrix, no. So okay, no. So I can also perform on operations like M, okay, M times, okay, that times, okay, M. So let's see what, okay, sorry, no, that's wrong syntax, no. M dot times M, okay. So here, no, meaning matrix M times matrix M is, let's what's gonna happen, no. So 1 4 9 16, so meaning 1 times 1 here, no, this, because the original matrix is M, no. So 1 times 1 is 1 times 1 is 1, 2 times 2 is 4, okay, 3 times 3 is 9, and 4 times 4 is 16, no. So what if I'll put an operator M and then times or plus, no, mag-plus ko og 1, no, mag-plus ko og M, okay. So what's gonna happen? So 4, no, so meaning 1 plus 1, because our, I hope, you know, you remember that we assign a vector, a matrix M with this one, no, with this one, 1 2 3 4, no. So Octave remembers that, no, although we clear screen that previously, but since we're working in same window, no, so when M plus M, meaning 1 plus 1, so meaning M itself, no, plus itself, no, so meaning 1 plus 1 equals 2, no, and 2 plus 2 equals 4, 3 plus 3 equals 6, and 4 plus 4 equals 8, no. So that is the operations of matrix, no, in an Octave. So I'll clear screen that, and we will go back to another topic, no. So next is we have what we call spatial matrices, no. So here are the special matrices, okay? So meaning special matrix ni siya, okay? So we have what we call ones, no? N and M. So meaning it generates a matrix n times m, no? Of ones, no? So meaning, so we have what we call also zeros of n and m, which generates a matrix n and m or zeros, no? So we have also an I, n or I and m generates identity matrix. We have also the functions of rand, and we have also the fraction of rand end. Okay, so later we will see what's the difference between rand and rand end, no? So in our example, no. Okay, no. I hope you're still there, and don't be kuan lang. Ayun lang sa it's kuan lang. Let's start it slowly, no? So these are still the basic function of Octave, no? So last time I think I've shared you long documents, no, about Octave, and you can read it, no? So anyway, this discussions recorded, no? You can double check, okay, review, or see that recordings, no? Okay, so we will perform the Octave examples of special matrices as listed here, no? So we will go to Octave, and it's clear screen, no? So do you have questions, clarifications so far? Class?
Asa gina siya ang Octave, sir?
Actually, ma-download na niyo ang Octave because this is free software naman siya, no? So you can check it here, no? This is the link, no? Kading http www.gnu.org, or you can search in the Google and download to your PCs or laptops, no? Unfortunately, hindi siya downloadable via app in a cell phone, no? Okay? It's up my questions before we proceed to special matrices topic. Basic pa din siya, class, ha? Lisod or confused? Of course, no? Basta bago pa, medyo confusing siya. But I believe most of you is kanang mga computer major man mo. So this is actually kanang equivalent to your programming, no, subjects. Okay, so we will proceed, no? We will have some examples on special matrices. Okay, so we have ones, no? Ones. Okay, so sama ni siya. Okay. So halimbawa, we have 3 and 3, no? So let's find out to. So meaning we generate a matrix, no? A 3 by 3 matrix with ones, no? So that is the output, no? So we have 3 by 3 matrix, so meaning 3 column, 3 column matrix, no? By ones, no? So we can also generate a 0, no? So we have 0, okay, and 4 by 4, for example, okay. Okay, so sorry, no, medyo sayop, no? 0, okay, bas sample 3 by 3. Okay, dali lang, ha. Zeros di ay na is di ay. Okay, so zeros, and we have, for example, 3 by 3. Okay, so Sayop man. Three by 3. Okay, so gamay day nga z, no? Zeros 3 by 3, no? So we have also a 3 by 3 zeros matrix, no? So okay, no? So we will check on the I, no? Summoning I, no? I, okay. So sample I, and we have 4 sample, no? So meaning we've just constructed a 4 by 4 matrix with one diagonal, no? Did you see this 1, 2, 3, 4 diagonal 1, no? So this is what we call generate identity matrix. So meaning identity matrix, no, with an I. So meaning I here is this one, no, the diagonal, the one diagonal, no. So for example, no, we will also run, no, we will perform the run function. For example, 1.5, okay, 1 comma 5, no. So 1 is the row and this is the column. So meaning we generate a random numbers from 1 to 5, no? So this is the random generations of number, okay? The 5 numbers, no? So we've generated a number, no? Okay? 5 numbers, 1, 2, 3, 4, 5. This is 5. Okay, look at generate n, okay, n times m matrix of uniformly random elements, no? So this is the m, this is the 5, okay, and 1 here is meaning we've generated a random numbers less than 1, okay, and 5 is the number of that is the number, no? So meaning this is the m, okay? So what if we've also try to generate rand n, no? And let's find out sample 1 to 10, no? Okay, so 1 to 10, no? So here, okay, we've generate random numbers, okay? Random numbers, okay? 10 random numbers less 10 random 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, no? So run n, nm generates n times m matrix of normally distributed random elements. Okay, so uh, you can practice this at home, no? When you're able to download Octave, no? Okay, because next topic is we will be discussing medyo taas-taas na sa mga computations. Okay. And eventually we will have some applications, okay, for you to appreciate, no, kung unsa ka importante or unsa ka importante ang computer simulations in the industry, no, as an applications of applied mathematics, no. So we have here, no, we have here also indexing, no. So we have also indexing, no. So I will not discuss this further, no. You can practice this at home, and I have also here a help, no. So finally help command, no. This command will display the help for any function in Octave UAs, no. For example, help run, no. So let's find out, no. So naglibog ka, no. Sa unsa ning help, oh, help, okay, run, okay, okay. So mo display dire ang kuano, ang mo display dire ang what should be the functions, what should be the syntax of run, no. So mura na siya help, no. Actually help gini siya, no. So you can see the documentations on how to write or to correctly write the syntax for a certain functions, no. So again, no, you wanted to clear this window, so you just type CLC, no. So this is the basic operations of Octave, no. So I hope, no, you get some insights of it, no. Of course, no, again, no, mathematics, programming, and any other, no. Once you did not practice, no, so medyo makalimtan unsahay, no. So mas maigi itong makapractice ta, no.